Okay, here we're going to talk about the greatest common factor of two numbers, or how we can go about finding that. And I'm going to use my website here, and I'll give you a link in the description for this video if you want to go to this website. But just notice on the options over here that I have only selected greatest common factor. I'm not going to do least common multiple in this video, but I'll have another video for that. So the first problem we're going to look at here is the greatest common factor, or GCF, as it's written here, of these two numbers, 42 and 9. So knowing how to find the greatest common factor can come in handy sometimes for us, especially with fractions. So if I imagine that I had the fraction 9 over 42, and I wanted to reduce, if you know about fractions, you might remember that to reduce a fraction you have to divide on the top and bottom by the same number. Whatever I divide 9 by, I also have to divide 42 by. That's how reducing works. And sometimes we can reduce, and we can do it in multiple steps, but it's quickest to reduce if we divide by the greatest common factor. And what that means is we're looking for the biggest number. Let's type this out here. We're looking for the biggest number that will go into both of these numbers. So I'll just type that out here. The biggest number that goes into 42 and 9. Okay. And when I say goes into, I'm talking about division. So goes into, goes into, that's what I wanted. That means we're talking about division. So the biggest number that will divide into both 42 and 9. Okay. So here's how I like to do this. I like to start with just the smaller number. So let's just start with 9. And I like to make a little like T-chart here. Okay. This is how I organize my work. And I'm gonna on this T-chart I'm gonna write down numbers that I know divide into 9, numbers that I know go into 9. And we're gonna start always with 1. 1 will go into any whole number. That's always going to be on my list. And I think to myself, 1 times what equals 9? And so this is where I have to be good with my my math facts. 1 times what equals 9? This one's not very hard. It's 9. Okay, so I'm always going to start with 1 and then the number that's on top. 1 times 9. Those pair up. 1 times 9 gives me 9. 2 I'm going to write down, and I'm going 1 and then 2. But 2 does not go into 9. I know that 2 times 4 would give me 8. And, excuse me, 2 times 5 would give me 10. And I've passed over 9. Oops, 10, not 9. So I'm not allowed to use fractions or decimals here. It has to be whole numbers. So 2, I wrote it down, but it doesn't work. So I'm going to cross it off. After 2, I've got 3. So we go 1, 2, 3. And 3 goes into 9. I think to myself, does 3 go into 9? 3 times what gives me 9? And it's 3 times 3, 3 times itself. Okay. Now this is what is called, or I call, rounding out. When I have the same number on both sides, I don't have to check. I could go through and check 4 and check 5 and check 6, 7, 8, and 9. 9's already on my list. But once I have the same number on both sides, I'm done. So all the factors of 9, I'll just write them out here. Factors of 9, numbers that divide into 9. My complete list, and maybe I want to put it in order now. I've got 1, 3, and 9. That's it. Okay. But now, remember the original question, we're looking for the greatest common factor of 42 and 9. We're looking for the biggest number that goes into both 42 and 9. These are all the numbers that go into 9. There's no other number that's going to work. You could check 4 if you want, 5, 6, 7, 8, but I guarantee you they're not going to work. So now I'm thinking, okay, which of these numbers goes into 42? Does 9 go into 42? And I think to myself, 9 times what would give me 42? Oops, equals 42. And if I know my math facts, I know that 42 is not one of the facts for 9. We would have 9 times what? 9 times, let's see, why can't I think here? 9 times 4, there we go, would give me 36. And 9 times 5 would give me 45. I've passed over 42. So again, without using fractions or decimals, it doesn't work. So 9 is not a factor of 42. 3, let's try 3, because that would be the next possible biggest number, the next greatest. And you might not know if there is a number 3 times something that gives you 42. So you might have to do some long work here and do division. So you might try out 42 divided by 9, or excuse me, 42 divided by 3, and where's a good spot that I could put that? So how many times will 3 go into 42? Does it work out nicely? So real quick, 3 goes into 4 once. 1 times 3 is that. Bring down your 2, you got 12. 3 goes into 12 exactly 4 times. 4 times 3 is 12. We get no remainder. So that means 3 times 14 would give you 42. So yes, 3 is a factor. It's a factor of 42 and 9, and more specifically, it is the greatest factor that they have in common, the biggest number. So let's go back to the website. So we said 3 was the answer, and let's see. Alright, we got it. Awesome. Let's do another one. Alright, here we go with another example. We're doing the greatest common factor of 14 and 40. And again, the way I like to do it, I'm gonna take the smaller number, 14, and I'm gonna find all the factors of 14, all the numbers that divide into 14. Let me type that up here again here. The biggest number that goes into 14 and 40. That's really what we're looking for here. Okay, so I'm gonna start with the smaller number, and I'm gonna find all the numbers that go into 14. All the numbers that divide into 14. So remember, 1 will always go into a number, and it's 1 times 14. That gives you 14. Okay, so you're always going to start with 1 and the number that you're talking about. Next, after 1 comes 2, and I think to myself, 2 times what? Will 2 go into 14? I could check with division, but if I know my math facts, it's a little bit quicker to go, oh yeah, 2 times 7. 2 times 7 will give you 14. 1, 2, next would be 3, and I think to myself, 3 times what would give me 14? And again, if I'm good at my math facts, I know that I've got 3 times 4 gives me 12, and 3 times 5 gives me 15. So we're skipping over 14. Whoops, 3 times 5 gives me 15. There we go. So we skipped over 14. So 3 is not going to work. 3 is out. But I checked. I'm being methodical here. I've got a process. What about 4? 4 times what gives me 14? And again, I know that if I have 4 times 3, that gives me 12. And 4 times 4 gives me 16. So once again, we've missed. 4 is not going to work. But I wrote it down and I checked. 1, 2, 3, 4, 5. Will 5 go into 14? And that one I know does not work. There's no integer, no whole number, such that 5 times that number gives you 14. You would have 5 times 2 would be 10, and 5 times 3 would be 15. We've skipped over 14. We're trying to get 14. We've skipped over it. So 5 is out. Let's extend that blue line a little bit here. I only got one more number to check, thankfully, and that's 6. I won't have to check 7 because 7 is already on my list. And I won't have to check 8, 9, 10, 11, 12, 13. So 6 is the last one to check. 6 times what gives you 14? And once again, it's not going to work here. 6 is going to be off the list because 6 times 2 would give me 12, and 6 times 3 would give me 18. And by the way, you don't need to write all of this down here, but this is the thought process. This is what's going through my head. What I do want you to write down is over here, this T-chart. And I do want you to write down the 3, 4, and 5 and cross them off, or at least think of them in your head. But 6 is out. 6 will not work. And then 7 is already on the list. Whoops, let's make that a little bit smaller. 7 is already on the list. So I've rounded out, I'm done. I don't have to check 8, 9, 10, 11, 12, 13. These are all the numbers. So factors of 14, this is all of them, 1, 2, 7, and 14. Let's make a little space here. So here we go, factors of 14. This is the complete list. And now I'm going to check all of these, starting with the biggest, or well, check until I find one. 1, 2, 7, 14. Find one. Now I got to go to my other number, 40. I want to find which of these numbers goes into 40. So start with the biggest. We're looking for the biggest number. So let's start with 14. Does 14 go into 40? Well, we could do multiplication by 14, or we could do division. We could say 14 times 40, but actually that's going to be tough. Let's see here. 14 times 1, this might be better. 14 times 1 is 14. 14 times 2 is 28. 14 times 3 is 42. So if I'm doing my division, it would be 2 with a remainder, or 2 with a decimal. But overall, 42 is not, or excuse me, 40 is not divisible by 14. So that's out. Let's try 7. Does 7 go into 40? That one might be a little bit easier. 7 times what gives me 40? And that's easier for me because I know my math facts. I know that 7 times 5 is 35, and 7 times 6 is 42. So once again, we're going for 40. We missed. So 7 is not a factor of 40. How about 2? Will 2 go into 40? 2 times what will give you 40? And that one, hopefully you can do in your head. You would just take half of 40, which would be 20. 2 times 20 would give you 40. But again, if you're not sure, you could do it as long division. You could say, how many times will 2 go into 40? We're hoping for no remainder. 2 is our winner. That's the biggest number that goes into 14 and 40. It's the greatest common factor of 14 and 40. So let's put that on the website. 2, and we got it. Let's do one more. Okay, here's our last problem that we'll look at together. We're looking for the greatest common factor of 19 and 33. So again, to keep in mind what we're talking about, what does that mean? We're looking for the biggest number that goes into both 19 and 33, the biggest number that divides into both of them. So here we're actually going to see, I've been saying take the smaller number and find all the factors of the smaller number. Here we're going to see it might actually be easier to do the bigger number, but you'll see why here in a little bit. So remember that 1 is always a factor. 1, and it's 1 times 19. So always going to start with 1 and the number. But now I'm going to try 2, and I'm going to think to myself, 2 times what gives me 19? And if you remember, 2 is only goes into even numbers. 19 is not even. 19 is odd. It's not going to work. Or we could think to ourselves, 2 times 9 is 18. That's close. 2 times 10 is 20, and we missed 19. So 2 is out. But we tried it. 1, 2. Next, we're going to try 3. 3 times what gives you 19? 3 times 6 will get you close. Let's do that in red. 3 times 6 will get you close. 3 times 6 is 18. And then 3 times 7 is going to be 21. So we missed. So 3 is off the list. But we tried. 1, 2, 3. Next would be 4. How many times will 4 go into 19? Or 4 times what gives you 19? And again, we can get close if we do 4 times 5. We get 20. I'm going backwards here on this one. If I go back, 4 times 4 would give me 16. So we're missing 19. We're trying to get 19. So 4 is off the list. We could keep going here. What you're going to find is that if you try 5, if you try 6, 7, 8, 9, you really actually don't have to do 10, because 10 times 1 is 10, and 10 times 2 is 20. Everything else is going to miss 19. But you want to check. You might also know that 19 is a prime number. Which means that these are the only factors. 1 and 19 are the only factors of 19. That's it. There's no other number. That's called a prime number. So now again, I think to myself, it might have been easier to do 33, and I'll show that to you in a moment here. But I'm looking at all the factors of 19. There's only 2 of them, 1 and 19. And is 19, is that a factor of 33? Well, we could try. Let's make a little space here. We could try and say, let's do, 19 times 1, we know is 19. What about 19 times 2? And you could scratch that out. but I know it's 38. So I go, oh, I was going for 33 now, and I passed over it. I went from 19 to 38. So 19 is off the list for 33. 19 is not a factor of 33. So that means it has to be 1. That's going to be my winner. 1 is going to be the greatest common factor of 19 and 33. So let's try it out here. 1, check my answer, and we got it. Okay. Just in case you're interested, when this happens, when you get a greatest common factor of 1, that is called relatively prime. And you don't need to know that necessarily for prime numbers, or excuse me, for whole numbers or for fractions and decimals, but it's a term in math. We say the two numbers, 19 and 33, are relatively prime to one another. 19 is a prime number all by itself. Two numbers together are relatively prime if their greatest common factor is 1. But then I said I was going to show you that it might be easier. Instead of saying, well, 2 didn't work, 3 didn't work, 4, 5, 6, 7, 8, 9, you may have gone all the way up to 18, but it's only 1 and 19. So let's try it if we do the factors of 33, because that might be easier. So we try and find all the factors of 33, and you might say, well, yeah, that was a little bit easier than going through all those numbers for 19. So remember, I'm always going to start with 1 and the number. 1 times 33 gives me 33. I'm going to look at 2, but I know, well, 33 is odd, so it's probably not going to work. And let's see here. I know that 2 times 16, or if I do, I might want to do 33 divided by 2. This might be easier. We want to get a remainder of 0. 2 goes into 3 once. 1 times 2 is 2. Remainder of 1, bring down 13. 2 will go into 13 6 times. 6 times 2 is 12. Subtract, you get a remainder of 1. And that is not allowed. So that means 2 times 16 would give us 32. 2 times 17 would give us 34, and we're skipping over. So 2 is not on the list. But we tried it. 1, 2, next would come 3. 3 times what gives you 33? And hopefully you know this one, even though not everyone does their math facts with 11, multiplication by 11, but that's what it is. 3 times 11 will give you exactly 33. So that pairs up. 4 times what would give you 33? Well, let's see. 4 times 8 is 32. I'm running out of room here. 4 times 8 is 32, 4 times 9 is 36, and we were going for 33, and we missed it. So 4 is off the list. 1, 2, 3, 4, let's try 5. 5 times what? And again, I'm gonna go a little bit quicker here, but I know that 5 times 6 is 30, 5 times 7 is 35, so we missed 33, so 5 is off the list. What about 6? Well, again, 6 times what gives you 33? That's not going to work. 6 times 5 is 30, 6 times 6 is 36, so 6 is off the list. 7, how about 7? 1, 2, 3, 4, 5, 6, 7. Again, I'm going a little more quickly here, but 7 times 4 is 28, 7 times 5 is 35, so we missed 33. That one's off. 8, we only have to do 8, 9, and 10, because we already have 11 on our list. But 8, 9, and 10, what you're going to find if you try these, they do not go into 33. So all of those, try them, but they're not going to work. And then we've rounded out. Again, after 10 comes 11. 11's already on the list, so I'm done. I don't have to check 12 or 13 or 14 or any other number. This is my complete list. So now I would come back then. That was still kind of hard. But now I could come back and I could say, okay, well, let's start with 33. Is 33 a factor of 19? Does 33 go into 19? No, because, let me switch colors here, but no, because 33 is too big. What about 11? Does 11 go into 19? Nope, 11 times 1 is 11, and 11 times 2 is 22. We were going for 19 now, and we missed it. So 11's off. What about 3? 3 times something to get 19. No, 3 times 6 is 18. 3 times 7 is 9. Or excuse me, 3 times 7 is 21. We were going for 19 now, so we missed it. So 3 would be off the list. So again, we come down to 1. 1 is the only common factor, so by default it's the biggest common factor. Okay? So sometimes not necessarily the smallest number would be the best, but sometimes you might say, well, 33, I can do 33. 19 might be a little more difficult. So you got to make that decision, but you only really need to do one of them. Do your T-chart for one of the numbers. And then once you have that complete list for 19 or a complete list for 33, once you have a complete list for one number, check it against the other number. Do any of those numbers on your list go into the second number? One will always work, but again, we're looking for the biggest number. That's what we want. All right.